All right, we're back, guys. Our next concept with working with properties of exponents is power of a quotient. Okay, let's see what this is involved with. So right now we have a ratio inside of those parentheses, and everything in there is taken to the power of m. So as you can assume, you're almost going to distribute that m to both of those bases. So now you'll have a to the m power and b to the m power. Let's look at a number example. So again, two different bases, just like a and b are different, 3 and 2 are different. So we're going to just kind of distribute the power of 7 to both of those bases, giving us 3 to the 7th power and then 2 to the 7th power. Pretty simple. Let's try the two examples below. So our first base here is c to the first power. And we know when we take power to a power, we multiply, but keep the exact same base. So right now we're going to have c, 1 times 6 is going to give me 6. Underneath, we have d to the 5th power. 5 times 6 is going to give me 30. So power to a power, we multiply. Remember, we learned that property a couple properties ago. All right, here's another one for us. So in letter B, the negative symbol is going to go with the 2. So right now, I'm just going to rewrite this. And that power of 4 is going to go to both of those bases. So 1 times 4 gives me 4. The y underneath, 1 times 4 again, bring it y to the 4th. It's as simple as that. Go ahead and try the student's turn. So for these examples below, we're going to put a couple of those properties together. All right, let's check out the first one. The first thing I notice is that we have several bases inside of those parentheses. So I'm going to make sure that I put an exponent of 1 on all of them. Now, the next thing I'm going to do is everything inside the parentheses that I can do. So I can simplify with the a's up top right now. And since I have the same base and I'm multiplying across, I can add my exponents. So right now, inside my parentheses, I'll have 3 to the first power. When I simplify that, I'll have a to the 5th power over 5 to the first power and b to the first power. Almost forgot that one. I'll take it to the power of 3. I'm only putting the exponent of 1 so I remember to multiply, okay? So now I have the base of 3, and I'm going to multiply my powers. So I'm going to have 3 to the 3rd power. 5 times 3 is going to give me 15. A to the 15th power over 1 times 3 gives me 5 to the 3rd, and then b to the 3rd. We can simplify a little bit more there using your calculator. You can throw 3 to the 3rd power in. I believe that is 27. And then a to the 15th over 5 to the 3rd. I believe that's 125. And then b to the 3rd. You might be able to simplify that further, just in case. We'll double check. So I'm just going to put 27 over 125 into my calculator as a fraction. If it can simplify, it will. Nope, doesn't simplify. We're all good to go with that one. Lastly, our next example. I really like this example because although we have a situation of multiplication on the bottom, they're not similar bases. So I actually can't simplify that right at this point. So I'm going to kind of distribute this power to a power here to all 3 of those bases. So I'm going to get x to the 21st power, because 3 times 7 is 21, over x to the 14th power times y to the 21st power. Those parentheses are now dropped, so I'm going to bring this over. 1 over 3x to the 8. All right, so far so good. I'm going to multiply across the top and the bottom, and then I'll simplify from there. So anything times 1 is itself, so I have x to the 21st power. That's done. On the bottom here, my number goes first. So I'm going to have 3. Then my x's, when you have the same base and you multiply across, you add your exponents. So I'm going to end up with x to the 22nd power. And then y to the 21st power. All right. We're going to simplify a little bit further here. And we're going to have x to the 21st power over x to the 22nd power. So if we have 21 x's on top and 22 x's on bottom, we know that all of these will cancel out and leaving us with just one x on the bottom there. So up here I'm going to have the 1 to keep a placeholder. On the bottom I'm going to have a 3 and y to the 21st power because there's nothing to simplify there. All done. Alright, last two examples. We're going to distribute that power 5 to everything inside the parentheses first. So we'll have a to the 35th power, because 7 times 5 is 35, over 2 to the 5th, a to the 10th, b to the 5th. And I'm just going to bring over that a, b. I'm going to throw it over 1 so I remember that stays on top. Alright, next we'll multiply across the top. A to the 35th times a to the 1st gives me a to the 36th. Next I'll just have that b there. On the bottom, 2 to the 5th power is actually 32. Remember, that's not 2 times 5. That's 2 times 2 times 2 times 2 times 2. So if you don't have a calculator that you can put an exponent in, just remember to do it as many times. Multiply that number as many times as the exponent is. So that's going to be 32 times 1, so it's going to be 32. And then I'm going to have a to the 10th and then b to the 5th. All right, we got to simplify by subtracting as we divide down. So let's look for our similar bases. Grab another color here. We'll get green. So we have the a here and the a here. 36 minus 10 would give me a to the 26th power. All right, so that simplified and that simplified. Now we have b to the 1st here and b to the 5th. So if I subtract those, technically I'm going to have b to the negative 4th power. We'll talk about that a little bit later. So that's simplified, and that's simplified, and then the 32 is still going to be on the bottom. Now I will tell you that this is not completely simplified because you can't have negative exponents, but that's what we're going to learn in the next lesson. So we'll just keep it like that for now. It's okay if you had a 1 in the front here, but you don't need it. Last example here, let's go ahead and distribute that power 2 to everything inside the parentheses, giving us 3 squared x to the 6th over 2 squared y, and then y squared. Nothing to distribute here, so I'm just going to bring everything over. But I can simplify things inside here first. So if you wanted to do that first, that's fine. If you wanted to multiply across and then simplify down, that's up to you. I think I'll simplify first because it'll be easy. If I have 1 x up here and 2 there, if I simplify that, think of it like an x over x times x. If I simplify one of those x's, I just have an x left on the bottom. So now these will simplify to just x on the bottom. Similar here with your y's. Got 3 y's on top over 2 y's on the bottom. That's written out in the long form. If I can simplify, those would cancel out, those would cancel out, and there's 1 y left on top. So now when I multiply across the top, it'll be a little bit easier for me. 3 squared is going to give me 9. X to the 6th times nothing that's similar gives me x to the 6th, and then just y. 2 squared is going to give me 4. Then I'm going to put my x first, so there's my x, and then y squared. All right, let's think about the same thing here when we simplify. Over here, 9 over 4 will not simplify, so I'm going to keep that exactly like it is. I have 6 x's on top and 1 on the bottom, so if I subtract those, I have x to the 5th left over on top. Similarly here, we have 1 y on top, 2 on the bottom. If I subtract them, or if I look at it this way, more so, you'll have, and I'll write it up here. So you have a y on top, 2 y's on the bottom. If I cancel those out, I'll have just a y left on the bottom. I want to show it to you in that way because in our next lesson, it will kind of help explain why things end up where they are. So with the properties of exponents that we're going to be learning, we would know to simplify the negative exponent, and that kind of shows you why. All right, see you in the next lesson.